This is lesson 1.5, part B, and the objectives for this lesson are to solve a quadratic equation by using square roots, just like our last lesson, and also you will be able to model the height of a dropped object over time using the quadratic equation. So let's just take a look at a couple of examples to start with that we know how to solve before we get into the modeling with the quadratic equation. So for example 1, we have this problem A, x squared minus 6 equals 43. So first of all, I want to get everything to one side that I can get to one side because they're similar things. These, the negative 6 doesn't have an x with it, so I'm going to go ahead and add 6 to both sides so I can cancel that. And I end up with 49 on the right. And I know that I can take the square root of both sides. Taking the square root of x squared is going to be x, and taking the square root of 49 is going to be plus or minus 7. So one of the things that you want to remember is that your answers, when you take the square root of something, are always going to be plus or minus. So please include that with your answer. And for part B here, it looks like we can get rid of this negative 8 if we add 8 to both sides. That's going to be my first step. And then I'll have 3 times the quantity x minus 2 squared equals 48, because those 8's cancel. And if I divide both sides by 3, then I'm just going to have x minus 2 squared equals 16. And the next step, basically now I can just take the square root of both sides. And remember, the stuff that's left in here, this part right here is what's going to be left, because we're basically taking away the square when we take the square root of this side. So my next part of my equation is going to be x minus 2 equals 4, and 4 came from the square root of 16. Actually, that's going to be plus or minus 4. All right, so now I'm going to have two answers. So I'm going to do that up here. I'm going to have x minus 2 equals negative 4, and x minus 2 equals positive 4. Okay, so when you see the plus or the minus and you still have something else on the left, you kind of have to split it into two, because we want to have two answers, but they're not going to be super simple to get because I still have this negative 2 over here to deal with. So my next step is going to be to add 2 to this side and add 2 to this side. So it looks like x is going to be equal to negative 2. That's one of my solutions. And if I add 2 to this side and add 2 to this side, then I'm going to have x is equal to 6 as well. So what we mean by this is these are the two places that the x-axis is going to be hit by that quadratic equation, or that parabola, when it's graphed. So if we were to graph this quadratic equation, we would end up with a parabola that hits x at negative 2 and hits x at 6. So that's what the meaning of those things is. Okay, let's go ahead and get into the modeling of dropped objects. So this is the equation that we're going to use as a standard equation. Okay, so it means that when you drop an object, okay, it can't be thrown, but it can be dropped from a height h. Okay, so we don't know what the height is necessarily, but from a height h above the ground after t seconds, notice that t right here is squared, can be modeled by this function. So it's going to be h equals negative, because negative would indicate that it's going down, right? Negative slope or negative value before the squared variable. Negative equals down, or downward, remember. And so then it's going to be plus HO. Now HO is the initial height. This is the height of the object initially, or when we start the problem. All right, and so this model assumes that there's no resistance from air or wind and the object is dropped on Earth. Okay, and the reason for that, and you might get into this if you take a physics class, there's gravity involved, obviously, and so gravity has something to do with how things fall and how quickly they fall. So if we were, in space or something, it wouldn't be the same. So we want to make sure that we know that this formula only works when we're talking about a height in feet. Okay, that's what the negative 16, has something to do with, and also that we're doing this on Earth because gravity is already calculated into this equation. So I don't want to get too fancy and too into the physics of it, but I do want us to remember to use that formula. So let's look at first example number 2. For a science competition, students must design a container that prevents an egg from breaking when it's dropped from a height of 50 feet. How long does it take for the container to hit the ground? So how long means that we're looking for time. And in our formula, t squared represents that variable of time. And so if we recall that the height is going to be 50 feet, okay, and so that's the initial point at which the egg is going to be dropped. So we need to set up a formula that says h is equal to negative 16 t squared plus 50. And remember, when we solve a quadratic, we have to set it equal to 0. So instead of having an h over here, I'm going to make this a 0. So 0 is going to equal negative 16 squared plus 50. And besides that, when the egg hits the ground, it is going to be at 0 height. So that's what we're measuring, from 50 feet up to 0 feet, the actual ground. That's why we were going to make h into 0. So subtracting 50 from both sides, my equation is negative 50 equals negative 16t squared. And if I divide both sides by negative 16t, that's going to get rid of my negative, and I'm just going to end up with 50 over 16 equals t squared. And if I take the square root of both sides, the 16 on the bottom becomes a 4 because the square root of 16 is 4. And I just want to recall, or help you recall, that it's going to be a plus or a minus, because when we take a square root, it's always plus or minus. So 4 is on the bottom. And on the top, the factors of 50 are going to be 25 and 2. So those things we can, that's equivalent to the square root of 50. The square root of 25 is just 5. And we can't do anything with the square root of 2 because it's a prime number. So this is our final answer. We probably would get rid of the negative value because there is no negative time, there's only positive time. And if I took my calculator out and I actually took out and said 5 times the square root of 2, right, if I did that and then I divided that by 4, I would get an actual amount of time, which would be 1.77 seconds. Okay, so if you think about it, an egg falling from 50 feet, which is taller than our high school building, it probably would take about 1.77 seconds for an egg to drop. And you want to make sure that when you get an answer to any of these word problems, it actually makes sense. Don't just write something down because you had some trouble calculating, but start thinking about, does it make sense that an egg would take almost, not quite, but almost 2 seconds to fall 50 feet? On the back side of your paper, there are a few more examples, so let's take a look at example number 3. Seagulls drop clams on rocks in order to break them. Suppose a gull drops a clam from a height of 72 feet. Our formula to solve this is going to be h equals negative 16t squared plus h sub 0, which just means the initial height. So this information came from the other side, and so we just have to fill in what was the initial height. And our initial height was 72 feet, so h equals negative 16t squared plus 72. So this is the actual quadratic equation. Now they want us to find out when will the clam hit the ground. So we're going to be solving for t. In order to solve for t, I need to set my equation equal to 0. And once I do that, I can subtract 72 from both sides. There should be a squared right there. Okay, and I just flip the equation around so I have my variable on the left. Negative 16 is what I'm going to divide by on both sides. So t squared equals the square root of 72. Well, I'm not going to take the square root quite yet, but 72 over 16. I'm just getting rid of the negative signs there. And I can take the square root of the top and take the square root of the bottom and take the square root of t squared, and I end up with t equals 4 on the bottom, and don't forget to put your plus and minus in there, although when we're thinking about seagulls dropping clams and talking about time, we don't generally have a negative value. And so on the top I'm going to have 72 is 36 times 2, right? So if I take the square root of 32 and the square root of 2, I'm going to end up with 6 root 2. And just a reminder that you cannot do anything with the square root of 2. That's a prime number, so therefore it stays under that radical symbol. But the square root of 36 is 6. Now if I actually took my calculator out and did 6 times square root of 2 and divide by 4, t is about 2.12 seconds. Okay, now if you think about the amount of time that it took for the egg to fall 50 feet in our previous example, and how long it took for a clam, which is about the same amount of weight as an egg, but it took 2.12 seconds because it went further, right? It went 72 feet instead of 50. Example number 4 asks us to do similar work as we just did. We have to write a quadratic equation, and then we want to find out when the clam is going to be 5 feet from the ground. Okay, we're not going to let it fall all the way to the ground, but how long is it going to take to get 5 feet above the ground? So perhaps it's, hitting a person on the head, or it's hitting a cliff on, with the clam or something like that. So we're back to seagulls dropping clams on rocks. And suppose a gull drops a clam from a height of 55 feet. Okay, so this is the initial height, and the amount of time that it takes to get to 5 feet is what we're going to be solving for, but we have to make sure that we put 5 into our quadratic equation. So our equation is going to look like this: 5 equals negative 16t squared plus 55. Now the reason I have a 5 here is because when this equation or when this situation ends, the clam is going to be 5 feet from the ground, and anytime something falls to the ground, we're going to use 0 for our height, our ending height, and our initial height is always what's going to go after the plus sign there. So if I go ahead and start solving this, I'm going to subtract 55 from both sides, so I end up with negative 50 equals negative 16 t squared. So I did not write down that I'm subtracting negative 50, but I'm just moving from that step to the part in part B here. And I do need to divide by 16, negative 16. Those negative signs cancel, so I end up with t squared equals 50 over 16. Now we've seen this before, so just so you know, we already know the answer. This was from example number 2. We saw the same fraction. When we take the square root of both of those, we end up with t, oops, got to take the square root of this too, t equals 5 root 2 over 4. So still plus or minus, but again, I want you to get into the habit of using plus or minus, but when we're dealing with time, there's no negative time. So this was going to be 1.77 seconds. Okay, like I said before, you want to think about if it makes sense. We had 1.77 seconds when an egg fell 50 feet, and this time a clam fell 50 feet, and a clam and an egg have a similar weight to them, so you can assume that they would probably take about the same amount of time to fall those 50 feet. All right, so we have 2 problems left. I would like you to try this one on your own. That's example number 5. And I'd also like you to try example 6 on your own. So I'm just going to give you a little hint about each one of them. Example number 6 is like example 3. Okay, so the reason it's like example 3, because the cliff diver here is falling all the way into the water. So from 40 feet up to the water line will be 0 height. And example number 5 is going to be like number 4, because this person who is walking on the sidewalk is 6 feet tall. So if she wants to avoid the bottle of washer fluid that's coming her way from 24 feet above, how long does she have to get out of the way? Well, she's 6 feet tall, which is kind of tall for a woman, but that's, for this problem, we want to make sure that we include that. If she doesn't want to get hit in the head by the bottle that's falling, then make sure you include that number 6 in the problem, and that's going to be like number 4, where the shell fell to a point of 5 feet above the ground. All right, so finish up example 5 and example 6, and make sure you ask specific questions if you're confused about anything.